So for a long free response question, we were given the mass of the potassium iodine, the mass of the thoroughly dried filter paper, mass of the filter paper plus the participant after the first drying, second drying, and the third drying. We were also given the amount of water and the excess amount of potassium nitrate. So for 1A, we took potassium iodine and lead nitrate and combined them to create a balanced equation. And then we split the aqueous elements up and created a net ion equation. And the net ionic reaction is the best one because it leaves us with the atoms or molecules that are changing or forming, leaving out any spectator ions that didn't change within the reaction. So the purpose of drying and weighing the filter paper 3 times was to get the most constant mass so that the percent error will be lower and that no water is also present in the filter paper. So we found out that potassium is less than nitrate because in the potassium iodine tablet, it was reacted with an excess amount of lead nitrate. And because of this, more nitrate atoms would be present in the filtrate rather than potassium because it was in an excess of potassium. In order to find the number of moles of participate that is produced in the experiment, we had to subtract the mass of the filter paper plus participate after the third drying minus the mass of the thoroughly dried filter paper to find the amount of grams in lead iodine, and we got 0.236 grams. So next we did stoichiometry to find the number of moles of potassium iodine, and we got that it was 5.12 times 10 to the negative 4 moles. To find the mass percent of iodine in the tablet, we took the number of moles in lead iodine, which we got in the last question, and we did mole ratio, and we got the moles in the ionic equation that we did in the A1. And then we just used a molar mass, and we got the number of grams of iodine in a tablet, which is 0.130 grams. And then to find the mass percent, we used a formula, which is mass over total mass times 100, and we got that it was 30.6% of iodine. So we said in part F that the iodine ions would stay the same because it would still react with the excess lead ions, and all the water is already dried off while masking the participate, so it would not affect the participate. If we substitute AgNO3 for lead nitrate, it will result in a precipitation of iodine ion because in excess of 0.20 moles of AgNO3 will create an insoluble solution, AgI, and it's supported because it has a low Ksp value. So finally in G2, a student can't determine the mass of AgI produced to 3 sig figs because when massing, you can only obtain a value within 2 decimal places and you can only have 2 sig figs, so you can't have 3 sig figs.